With the aid of a string, a gyroscope is accelerated from rest to 32 radian per second in 0.40 seconds. A. What is its angular acceleration in radian per second squared? B. How many revolutions does it go through in this process? Alright, so what are we given here? We are given initial angular velocity, which is 0. So it has to start from 0. And it reached an angular velocity of 32 radian per second. And that happens in time t, which is equal to 0.40 seconds. And what's A asking for is the angular acceleration alpha. And we know that alpha is equal to change in angular velocity over elapsed time t. That's omega f minus omega naught divided by the elapsed time t. And that's 32 radian per second minus 0 divided by 0.40 seconds. This yields 80 radian per second squared. B. How many revolutions does it go through this process? And that's basically asking delta theta, but in revolution. That's it, in revolution. So now here we have three options. We can use delta theta is equal to omega naught t plus half alpha t squared. We can also use omega f squared minus omega naught squared divided by 2 alpha. But the easiest of all will be just to use the average. Therefore, delta theta is equal to average angular velocity times time. And the average angular velocity is the average between these two velocities, the initial and the final. Divide that by 2, multiplied by time. That's the easiest. All right, and that's equal to omega naught is 0. Omega f is 32 radian per second. Divide that by 2, multiplied by the time, which is given to be 0.4 seconds. And that yields 6.4 radians. But we are asked to give it in revolution. Therefore, we need it in revolution, so we multiply by 1 revolution and divide by 1 revolution equivalent radians, which is 2 pi radians. Radian goes with radian. We are left with revolution for the unit, and then 6.4 divided by 2 pi is 1.02. So this is going to be 1.02 revolution.